Hello everyone. Let us start our next topic that is function. Function. The definition of a function says that it's a single value uh, function. It is even referred to as a single valued function. What is the single valued function and how a function is denoted, which is called as a pre-image and which is called as a range. We shall see here. And let x, a and b be two non-empty sets. Okay, then a function or mapping f from A to B is a relation from A to B such that for each A in the set A there is a unique B in B. That means every element of a set A you will be having a unique element in B such that A comma B belongs to F. Then we write function as f of A is equal to B. It means some element A is related to B. Here B is called as a image of A and A is called as a pre-image of B. So B is called as a image and that will be from set B, and A is called as a pre-image of B under F. The element A is also called an argument of a function F, and BOF of A is called as a called the value of the function is called as a value of the function for the argument A. We'll all see in the example when we take a different types of an example and also here we have some example and which will definitely help you to understand. A function f from a to b is denoted by, so this is the way in which the function is related, is denoted a to b. So it means that an element of set a is related to the elements of set b. This pictorial representation f is known as is shown below. That is whenever we write f of x is equal to x square, so some value of x will get a different value for y. So y is equal to x square means some, if you put some value for x, so that will have an impact on y. Okay, whereas you change the value of x, there will be a change in the value of y. So that is what it is conveyed over here. It has to be emphasized that every function is a relation, but relation need not be a function. Relation cannot be a function, but a function may be a relation. Uh, Next, but a relation, because if R is related from A to B, then an element of A can be related to two different elements of B under R. So a function can in a function an element can be related to two different elements of B. So if at all any function from set A, if it is not related to B, so then it is not called as a function. So we shall see that also in the coming slides. In the example 1, f of x is equal to x cube. F assigns to each real number its ABC. F of 2 is equal to 8. Why f of 2 is equal to 8? 2 raised to 3, 8. And image of 2 is 8. So image of 2 means, so this is A and this is will be in A in B. For a function f from A to B, A is called as a domain of f and B is called as a codomain. So whatever we are writing at the left hand side, that is called as a domain, and B for this we call it as a codomain. The subset of B consisting of the images of all elements of A under f is called as a range of f and is denoted by f of A. So the subset of B, whatever the subset consisting of the set B, so those are all the images of the elements under A. So for that we call it as a range. The following observations you need not to worry about this. So there is a problem over here. So whatever I am shading, so from here you have to consider, let A is equal to 1 2 3 and B is equal to -1 0, and Rb is the relation from A to B defined by R is equal to 1 minus 1, 1 0 2 1 3 0. Is R a function from A to B? So here he has asked whether it is a function from A to B. The arrow diagram for the given R is shown below. So 1 1 1 minus 1 1 0 and 2 minus 1 3 0. So we observe that under R the element 1 of A is related to two elements, that is minus 1 and 0, and B is not a therefore of B. R is not a function. So we observe that under R the element 1 is related to minus 1, uh, is related to 1 of A, and it is related to two different elements of, that is minus 1 and 0, and B is not of B, minus 1 and 0 of B. So here 1 is related to minus 1 and 1 is related to 0. So this is, for this reason it is not a, R is not a function. And next A is equal to 1 2 3 and B is equal to minus 1. Let A and B be sum of, be same as in example 1. S be the function from A to B defined by, so here S is a function here. Is S a function? We observe that under S each element of A is related to a unique element of B. One is related to minus 1, 2 is related to minus 1, and 3 is related to 0. Therefore F is a function from. The previous example, this was related to, one was related to minus 1 and 0. For this reason it was not a function. So here uh, these unique elements are related to uh, the B, so that's why it is a function. So next we shall see what are different types of functions. First one is an identity function. Types of functions are important. Function f from A to A, such that f of A is equal to A for every A belongs to A is called the identity function. So here by in short form it is written as IF, or identity mapping on A. In other words, a function f on set A is an identity function if the image of every element of A is itself in this case f of A is equal to A. So it should be like uh, every image has its own free image, then we call it as identity function. The identity function defined on a set A is usually denoted by IA or 1A also. So it is denoted as identity function. And next, constant function. A function f from A to B such that f of A is equal to C for every A belongs to capital A, where C is a fixed element of B, is called as a constant function. So all the elements of A has to relate with a single element of B. So for that we call it as a constant function. Uh, all the images of all the elements of A have the same image in B. So for this it is called as a constant function. Onto function. It is even called as a surjective. A function f from A to B is said to be an onto function if for every element P of B there is an element A of A such that f of A is equal to B. So in other words, f is an onto function from A to B if every element of B has a free image in it. So if every element of A has a free image in A, so then we call it as a onto function. If f of A is equal to B, that is range of f is equal to the codomain of f. And onto function is also called as a surjective function. So here whatever the image is there, it should have a free image on A. So for that we call it as a onto function. In other words, f is an onto function from A to B if every element of B has a free image in A. So all the elements on of A of B should have a free image in A. So then we call it as a surjective function. Next we have injective function. We'll see this later on. First we shall cover the types of that surjective and injective one-to-one function. A function f from A to B is said to be a one-to-one function if different elements of A have different images in B under F. That is, if whenever A comma B belongs to R with A1 not equal to A2, then f of A1 is equal to f of A2 not equal to f of A2, or taking equivalently that if whenever f of A1 is equal to f of A2 for A comma B belongs to A, then A1 is equal to A2. Even element of A has a unique element in B. So here elements of A has a unique elements in B. So for that we call it as a one-to-one function. A function is said to be one-to-one if different elements, see this, these are the different elements of A have different images in B. These are not having the same images. This has this image, this has this image, this has, this is the image, and this has this as an image. So this is called as a one-to-one function, one-to-one correspondence. This one-to-one function is also called as an injective function. And now bijective function, one-to-one correspondence is even called as a bijective function. A function which is both one-to-one and onto is called as a one-to-one correspondence or bijective. So what is that one-to-one? One-to-one we saw just now. Onto function and combination of one-to-one and onto is called as a one-to-one correspondence. So let us see an example over here. Uh, a function which is both one-to-one and onto is called as a one-to-one correspondence, or even if f belongs to f, a function from A to B is such that such a function, then every element of A has a unique image in B, and every element of B has a unique image, unique pre-image in A. So every element of A is having a unique image in B, and every element of B also should have unique image in A. So for that we call it as a one-to-one correspondence. So unique image, here also there is a unique image, and here also if you see this is having a unique image. So we call it as one-to-one correspondence. Next we shall see these examples even. Find the nature of the following functions: one f112223. See 1122, it is an identity function. We know that for every element A belongs to A comma A, if A is equal to f of A, f is an identity function. The time will be up now. We shall see the different examples, some more examples in the next video.